Good morning. Today we'll discuss the capacitors. Two similar capacitors are connected in parallel. In previous video, we have seen that the capacitor is double. The capacitance are this. If they are connected in parallel, suppose if the capacitor is a 2 microfarad and 2 microfarad, both are having the same values. If they are connected in parallel, the total capacitor will be 4 microfarad. If the capacitance is double that of one another, that of one capacitor. But connecting the two capacitors in parallel never double the area of the each plate of the capacitor. Okay, so that we have to think that what will be the value of capacitance. What will be the value of capacitance? So, but in general, the capacitance of the capacitor is proportional to the area of the plate. Okay, and when two similar capacitors are connected in series, then the capacitor total capacitance becomes half of the one capacitor. The total capacitance is half, but it doubles the thickness of insulation between the plate that are connected to the supply. So from this, we can say that when the two capacitors are connected in parallel, the capacitance value is double, but it never double the area of each plates. Whereas in case of the series connection, if the two similar capacitors are connected in series, the total capacitance is half, but it double the thickness of insulation between the plates that are connected to the supply, and therefore the capacitance of a capacitor is inversely proportional to the distance between the plates, and it is directly proportional to the area of the plates. That is the reason the capacitance is like directly proportional. It is directly proportional to the area of the plates, and it is inversely proportional to the distance between the plates. So there is a space between the charge plate of the capacitor, and in this space the charges set of the electric field. So there are the positive charge and negative charge. Positive charge on one plates and negative charge on the another plates, and this charge, the the electric field is set up, and this electric field will be there from the positive to the negative charge. So next is we'll discuss the electric flux, electric field strength. And the electric flux density. So let us consider one charge, and this charge will have place in the electric field. So this charge will experience, means the magnitude of force is experienced by this unit charge at any point in a field, and this is termed as the electric field strength out at that point. This will term as the electric field strength at that point, and therefore the electric field strength, it is generally denoted by E, which is equal to, suppose we have the capacitors like this, which is connected to this supply of 3 volt, and there is a positive charge there on this plate, negative charge on this plates. Okay, plus q coulombs, minus q coulombs is there, and this, the distance between these is d meters. So this is a d meters, and therefore electric field strength is nothing but V by B. So this is the electric field strength. E is equal to V by D. So this is the volts per meter. What is the unit of this? It is the volts per meter. Okay. So the two electric field of a system, uh, this electric field strength, which is the ratio of the applied voltage to the distance between the plates of the capacitors, and therefore total electric field of the system is described by the lines of electric force, and this is termed as the electric flux linking the system. So the flux is measured in the same unit, that is the charge, and therefore this is about the electric field strength. So next is about the electric flux density. So this is the measure of the electric flux passing at right angles through unit area. Okay, therefore this is denoted by the symbol D, and this is the measure of electric flux passing through at right angles through unit area. Therefore it is denoted by Q by 3. So this is a coulomb per square meter. This is a coulomb per square meter, and therefore from this equation A and B, we can write electric flux density B, electric flux density divided by electric field strength is equal to D by E. What is D? D nothing but this charge over E divided by electric field, that is D by D. Charge by E D by D. And therefore we can write this D by this is equal to this Q by C. What is Q? Q is equal to Q B. CB, and therefore here Q by V is equal to C. So instead of this Q by V, we can write here C, that is CB by A. So this in electrostatics, the ratio of the electric flux density in a vacuum to the electric field strength is termed the permittivity of the free space, and it is represented by the epsilon naught. So in electrostatics, the ratio of the electric flux density in a vacuum to the electric field strength is termed as the permittivity of the free space. Permittivity of free space. So this is the ratio of D by E. So permittivity of this free space is, this is the epsilon naught, it is equal to D by E, which is equal to CD by E. And this is a, therefore value of the capacitance C is equal to epsilon naught E by D, and this is a farads. Next is the relative permittivity. Relative permittivity. So the relative permittivity of different materials means we can increase the value of the capacitance. If you increase the value of this capacitance, it, if you introduce one more terms in this equation, definitely the value of the capacitance is going to increase. So therefore, it is found that the value of the capacitance is greatly increased. Okay, so therefore the relative permittivity of the different material is denoted by the symbol epsilon, and therefore the if the space between the metal plates of the capacitors is filled with the dielectric, then if suppose there is a space between this, and if this space is filled with some glass material, that means glass is a dielectric. So the glass is having the dielectric strength of 5 to 10, in this range of the 5 to 10. So if the dielectric, if you fill this space with this dielectric of the glass, definitely this capacitance value is going to increase. And when this it is filled with the dielectric having the relative permittivity, this is relative permittivity. So it is denoted by epsilon or suffix r, relative permittivity. So the glass is having the relative permittivity in the range of 5 to 10, and therefore if you fill with this dielectric material, then the capacitance between these two plates becomes C equal to epsilon naught epsilon r A over D. I have used the same equation. So now initially this factor was there. Okay. Now this factor was there. So we have multiplied by this epsilon r. So the value of the capacitance is increasing. So this is again farads. Okay. So and the charge due to this potential difference of 3 volt, you know that the Q is equal to CV. So if you put this value of C in this equation, epsilon naught epsilon r A by B into B, and this is a coulombs, and therefore the ratio of the electric flux density to the electric field strength is nothing but electric flux density to electric field strength is equal to, we have found this already, Q over A divided by V by B, and what we have got is Q over K into D by B, that is QB, and this VA. Okay, so instead of this Q, we can write here these values. To write this value of Q here, epsilon naught epsilon r AB by B into D by VA. This DB will cancel, this AB will cancel. It will remain there epsilon naught epsilon r. So this ratio of electric flux density electric flux density, the electric field strength is equal to epsilon naught, epsilon naught. And this is the P is the absolute permittivity. P is equal to epsilon naught, epsilon R. So where epsilon, this epsilon is the absolute permittivity. So this epsilon permittivity, absolute permittivity, epsilon is equal to epsilon naught, epsilon R, which is equal to C by E, which is also equal to CD by A, and therefore we can write that the unit is farads per meter, and the unit of absolute permittivity farad per meter, and this value permittivity of the free space. Value of epsilon of 8.85 into 10 raised to the power minus 12 farad per meter. So this is the absolute permittivity. The unit is farad per meter, and this is the relative permittivity, and this is the permittivity of the free space. Absolute permittivity, this is the relative permittivity, and this epsilon of the permittivity of free space. Okay. Therefore, in this way, by increasing the value, increasing the relative permittivity, the material, if you use the different materials for insulating purpose, then definitely the value of the capacitance is going to increase.